Thank you, Timpa. So, to talk about urban augmented reality, I first have to talk about augmented reality and tell you what I mean by that. This is a term I think that we're hearing more and more nowadays, and it often gets used to refer to things that most researchers probably wouldn't refer to as augmented reality. So I wanted to give you the definition that most AR researchers tend to use. So augmented reality refers to combining virtual stuff with our perceptions of the real world, of real stuff. And the idea is to do this in a way that is interactive, happening in real time, and I'm saying in a rather fancy way here, registered, that is to say, aligned geometrically with the things that are in the real world. To give you an example of this, I have some images at the bottom of the screen over here. This one is showing us part of a system that my students and I and colleagues built nearly 20 years ago. This is an AR system for assisting someone in assembling a space frame building made from a set of nodes and struts that need to be put together in the right order, in the right combinations to be able to go and make that which it is that you're supposed to be creating. And so here we're looking at some nodes, or rather one node and a couple of struts coming into it. This is just a photograph of the real world. And now we're seeing just a very, very simple overlay. This running on a very old system from the mid-90s. It was literally a rather underpowered, by today's standards, a personal computer running all of its graphics entirely in software. And it's showing a very simple bright red representation of a cylindrical strut, a little turning arrow indicating the direction in which part of the strut's supposed to be turned, to insert it into and attach it to the wireframe node, a little bit of text underneath it. Now by itself, this is of course rather simple and uninteresting looking, but if you look at the two of them together, you're now seeing instructions for inserting an appropriate strut into a particular node and then turning it the right way to make sure it's nice and tight. So this is just an example, in fact, of the fact that if you're adding things to what you see in the real world, you can very often get away with simplifying the things that are being added, very much the way that you would see simplified versions of things in, say, an instruction manual. So, combinations of virtual stuff with real stuff done interactively and done in a way in which the virtual things are geometrically aligned with physical things. Now, there's two really interesting consequences of this. One of them is that by making virtual content that supplements rather than replaces the real world, we need to pay attention to the real world. Okay? Basically, we're not ignoring it, we're celebrating it. And if we don't pay attention to it, we produce combinations that are going to be ineffective. And so the virtual content needs to be designed in such a way that it complements the real world, that it knows about what's there, that it doesn't obscure things that are important, and that in some cases it may itself be obscured by things in the real world that are important. If I were making a system, for example, that's designed to go and tell you about today's news, and it's overlaying what you're seeing about the news on your view of the real world, and as you're walking along, let's say a car comes barreling down the street and threatens to run you over, and you're paying lots of attention to what's happening in the news, that would not be a good thing. And so in that case, you want a system that would attend to the fact that getting run over is more important than learning about news, and therefore make sure that you're paying attention to the car and not to the news stories. So what kinds of things can we do in urban augmented reality? And I simply use this term to refer to augmented reality that has as its subject something about an urban environment. And so what I want to do is to partition things into outdoor versus indoor. It's one of many different ways we can think about taxonomizing stuff. And it just happens to be the one that I've chosen for this talk. So what can we do outside? One thing we can do is to give you information about the world around you. It might be sort of the information that you'd like to have as a tourist. And this is an example of a system that my students and I built starting in the mid-90s. The version that we're seeing over here is actually a little bit later. This is 2001. And we had done a system to tell people about the restaurants that were in the immediate environment around Columbia's campus for a conference that we were hosting at our department. And at the lower left, you're seeing what back in 1996, 97, and even in 2001 was the way in which we presented stuff to people. Nowadays, there are many AR systems that run, free ones in fact, that run on smartphones. There were no smartphones back in 1996, 97, or 2001 for that matter. And Moore's Law really does work, and all those wonderful things you do with your smartphone couldn't have been done 10 years ago with anything around the same size. And so what you're seeing here is a somewhat smaller version of the initially 45-pound backpack that we started off with in 1996. This one, circa 2001, is only around 25 pounds or so. Big, ridiculous backpack, that a lot of which you're not actually seeing. Antenna for the satellite navigation system that is bigger and bulkier than the one that's inside of your smartphone. A separate handheld computer being used in conjunction with a head-wear display. Now, interestingly, all the things that are actually in this system are trumped, are one-upped, are much less good than what's in your smartphone, with one exception, and that's the tracking that we're doing outside, which is done entirely with commercial off-the-shelf equipment, was being done with a kind of satellite navigation system that's much better than what's in your phone. And so what we were using back then, helped along by a local base station, which was sending correction information to it, in this system was literally centimeter level accurate. So we knew if you were over here versus over there. So literally accurate within a centimeter or two. Completely commercially off-the-shelf stuff. It's just very expensive commercial off-the-shelf stuff. Some more stuff. I just showed you the kind of thing that you might want to see as a tourist. Here's actually slightly earlier work that we did. This is from the late 90s, in which we were providing historical information about, in our case, what we knew well and was nearby, namely Columbia's campus. And here you're seeing overlaid on top of the main administration building, what used to be there before it was built, which is the main asylum building for the Bloomingdale Insane Asylum, which occupied what is currently now Columbia's main campus. Interestingly, in the same place in which the administration building is, a point that when my former dean found out about it, gave him a good deal of joy to realize that there was a reason for many of the feelings that he and many of the faculty had about the administration. Navigation. Figuring out where you are in the environment, how to get places. A very important thing we can do in an urban environment. And what we're seeing here is some work we did back in the late 90s, early 2000s, back before there were things like Google Earth and Google Maps. And what you're seeing at the bottom of the screen is a little representation of our campus, created from aerial photography. There's some 3D buildings that we can place on top of it. In this case, because we had limited computation power, we had literally only one of the buildings, the one that was the currently selected one, being shown in 3D at the bottom, which you can see if I only had a laser pointer, poking up from the top of that little panel of area at the bottom. And then you're seeing labels, which are being used to label all the buildings that are all around it. So the idea here is, by using augmented reality, rather than giving you a map that you can look at separately, you can now look at the environment around you and you can see the labels actually on it rather than having to look at the map and refer back to it. And so one theme that we're going to basically build on in our workshop, and that I'd like you to think of as a takeaway lesson if you're not going to be attending, is this whole notion that one of the benefits of doing things in AR is that you can integrate this additional information that you wouldn't normally have, the additional information that, let's say, a map gives you, with your view of the real world, rather than looking at the map and then looking at the world and looking at the map and looking at the world. And if you're anything like me, and I have a very bad sense of direction, it often takes a number of back and forth between my view of the real world and my view of the map before I get it aligned properly, and then after aligning it properly, figure out where exactly I am in the map versus where I am in the world around me. And when instead it's all integrated together, then something that's very hard for directionally challenged people like me suddenly becomes very, very easy. So what other things can we do with outdoor urban AR? Here's an example of an application to urban planning and design, particularly with regard to the environment. This is work that my former student Sean White did with me. And what you're seeing is overlaid on our view of the environment, these little red and green spheres. And it turns out what they are representations of carbon monoxide concentration. So Sean had basically put together a little carbon monoxide sensor, hooked it up via Bluetooth to a smartphone, used a system that we had that would let you do dead reckoning, tracking as you walked around in the environment. And then as you're walking around, those red spheres basically show you georeferenced information about carbon monoxide concentrations, where the concentration is being shown here by the height of the red spheres. The green spheres, interestingly, are all the same height because they're basically readings corresponding to where the red ones are taken from a single EPA-sponsored carbon monoxide sensor that happens to be at one place, and there's only one anywhere near where these are being taken, and therefore it's just getting a single set of readings. And we're just showing that reading as sort of a baseline relative to where the red readings are. And so one kind of cool thing that the urban planners and designers who are working with us in this project noticed is that if you look towards the end of the street over there, you'll notice there's some rather high red spheres. And so one question you might have is, well, what's going on over there? And if you actually see them not on a map, but on the real street itself, and you look around and walk towards the end over there where they were taken, you realize, the reason they're so high is that's where there's a bunch of cars that are idling before they actually get onto the highway, and so there's lots of exhaust that's responsible for the carbon monoxide over there. So again, you're looking at the real world and you're seeing this additional, otherwise invisible information that's overlaid on top of it. And finally, another example of navigation. This is work that we did back in the very early days of smartphones. This is a kind of first generation Android phone. And what this is basically an attempt to do something kind of like Google Street View, but doing it live. So it's the live view from the phone itself, the camera on the back of the phone, which is overlaid with virtual graphics that show the roads, which are labeled and obtained from a road database that we had. So we know where the phone is, we know how it's oriented, and then we're overlaying the road information on top of the actual real live view. So we can do stuff indoors as well, sometimes with different data sets, sometimes with the same data set. So here's an example of indoor urban AR, looking at the built environment of the inside of my lab from a number of years ago. This is my former student Blair McIntyre, working with colleagues who actually got the as-built plans for our lab, tried to correct them because, as I was intrigued to discover, as-built plans are not the way people actually really built anything. They're kind of the way they were supposed to have built it. And so in our case, for example, our lab was quite different in size and shape and content than what the as-built showed. And in this case, you're looking at a representation of the reinforcing bar, the rebar inside of a column in the wall, and a structural analysis done by a DOS program that people actually still used back in the 90s that could give you an analysis of that column with this rebar inside of it. So we can also do outdoor stuff inside. So if we know something about the Columbia campus, like the buildings and where they are, in this case we're showing one side of a conversation, a former student of mine, Blaine Bell, and the idea, he's looking at this scale model of campus where the buildings are labeled. You're seeing some additional pieces of virtual material. an agenda to the left, a copy of one of the buildings and an information sheet about it. And the idea is that we're now conversing about and maybe planning about what we're going to do with regard to the campus. And doing it not just by talking about it or looking at pictures, but having a real 3D model that we can interact with and also make sure that it doesn't block us when we're looking at each other. In this case, the system is actually attending to where the eyes are and making sure we can actually see each other. And on the other hand, this is work done back in the early part of the century, and the displays we were using back then, which actually are see-through, they weren't very see-through. So that thing that looks like it's really opaque on his face is just enough see-through that you can kind of sort of make out another person through it. But it's not as transparent as some of the things we have now. So what are some of the things we have right now? One of the things that we're interested in my lab, one of the current projects we're working on, is how we can combine together lots and lots of different kinds of technologies, not just, for example, the head-worn displays that I was showing you in the previous images. And in this case, what we're doing is we're taking personal tracked head-worn displays, personal tracked handheld displays, and combining them with, in this case, a shared tabletop display. So the idea is to make what we like to refer to as hybrid user interfaces that combine together lots of different technologies. And so in this case, we have a first generation, what nowadays is technically known as a pixel sense, used to be referred to as Surface by Microsoft before they co-opted the word Surface and used it to refer to a completely different system. But this is a rear projected multi-touch display, and it's not actually stereo capable, and even if it were stereo capable, it wouldn't look like this. That is to say, people often when they advertise stereo displays, they do something that is technically false advertising, because if you simply shot a still image of a stereo display and you only showed one eye, there's no way you'd know it was stereo. And so what people will typically do is they'll shoot the display at an angle and they'll show things literally looking like they're coming out of it, like those buildings over there. And this is typically what someone might show you if they were saying this is a stereo display. Now, what you're seeing here is an actual real picture of our system, and the reason those buildings can be violating, that is to say protruding beyond the bezel of the display, is they're not displayed on that display. They're displayed, in this case, on a head-worn display that's tracked, and so the system knows exactly where that head-worn display is attached to your head relative to the tabletop, and therefore, since we have these 3D models, we can display the 3D models looking like they're actually positioned, erected above the footprints on the physical tabletop itself. So the tabletop is showing essentially just the footprints of the building, kind of like, say, Google Maps or Google Earth. In this case, it's actually not Google Maps or Earth, because it's a Microsoft product done using Bing Maps. And the buildings look the way that they look because they're being seen on the head-worn display, which is its own separate display. This is one eye of a stereo display system. So in addition to showing that, we can also have other displays, in this case a handheld display. The little funny gray balls you're seeing coming out of the side of that display are part of a tracking technology that lets the system know exactly the position and orientation of that handheld phone. And in fact, we're using the same technology to actually track the head-worn display itself. And so in this case, we're seeing buildings, some of the same buildings we were seeing before, but we're also seeing some little placards on top of them. And what we're showing here is data that's been obtained about a variety of points of interest. It's gotten from a number of well-known social media sources, Yelp, Foursquare, Instagram, etc. That last one, NYC 311 or 311, is call logs for New York's 311 line, which is basically the, I have something I want to complain about, but it's not like life-threatening, so I shouldn't be calling 911 because this is not the right use of 911. So instead in New York you can dial 311 and then you can rant and rave about how it's 2 o'clock in the morning and someone's making noise, or your tire hit a pothole, or things of that sort that are kind of nuisances as rather than life-threatening. And so what we've done over here is we've taken these points of interest, information about them from a variety of sources, coalesced them, and then they're being displayed in these little summary grids of pictograms that you can see emblazoned on the sides of buildings. So what does this look like? I'm going to show you a little video now that I've sort of set the stage. This is shot through one eye of a head-worn display looking at this Microsoft PixelSense V1. So this is the Flatiron District in New York. And this is a multi-touch surface, so there's a law that says whenever you show a multi-touch surface, you must translate, scale, and rotate, or else you're not allowed to do anything with a multi-touch surface. So I, of course, had to obey that law. And now we're showing those little pictograms on the sides over there. And again, the building on top of their footprints, if you can't actually see what you're seeing over here because you're not wearing a head-worn display, at least you can interact with the surface itself. And in this case, as I said, we also have a smartphone that's all talking to the same system together. And now you can get additional information, for example, on things like that. This is a noise complaint over there, for example. And so all those things are working together. And the idea is that don't wear the head-worn display because you don't want to. You can still interact with the surface. You can still translate, rotate, point at things, ask questions about them. And if you have the head-worn display and or also the handheld, you can do more stuff. So you can take advantage of the different kinds of technology that are available in that case. So one question that you might have looking at this kind of stuff, these are all things we did in my lab. So the question is, when will this kind of stuff, when will urban AR become ubiquitous? So as ubiquitous as the smartphones, for example, that we're using in that last application. Well, it turns out there's a lot of applications right now that you can download for pretty much any smartphone operating system that will let you look around, hold in your hand, as you're seeing in these cases over here, smartphones, and be able to go and see through their cameras and take advantage of their satellite tracking and their inertial measurement units that do orientation tracking to be able to overlay various kinds of content on the world around you. Now, despite the fact that you can download these things for pretty much any phone, if I actually asked you the question, how many people here have downloaded one of these smartphone-based AR systems? So I see a reasonable number of hands, okay? How many people actually have used that system more than once? Keep your hands up. How many people use that system on a daily basis? Okay, I asked this question, this series of questions at the Augmented Reality event, which nowadays is called Augmented World Expo. It's a business-oriented AR conference where everyone there is in the business or wants to be in the business of AR. By the end of the last question, there was actually someone whose hand was still up. And then I asked, the last question was, you know, and keep your hand up if you don't work for the company that actually made the system. He kept his hand up, and he actually insisted, and he wasn't lying, that he really used the darn thing daily. But this is one person in a room of several hundred. So it's not exactly ubiquitous. You know, anyone can download it, it's free, that's great, but they're not ubiquitous. And so one question is, when will it become ubiquitous? My answer is, it's going to become ubiquitous when AR eyewear actually becomes ubiquitous. Because this notion of having to take your phone now, turn it on, hold it up, look around like this, you know, that's really weird looking, okay? And I don't think people, when they have the ability to do it, they don't do it, okay? Now there's other reasons having to do with the quality of the tracking. It turns out that the technologies used in phones right now don't really track well enough. They can get you within 10 feet, maybe even 10 meters, in some cases, sadly, a lot worse in others, of where you are. And what that means is that if there's something that the system is telling you is right in front of you, it might actually be right behind you, full 180 degrees in the wrong direction. It won't probably be miles off, probably won't be miles off. There are some cases in which, because of the satellite tracking and you're being, let's say, at the edge of a body of water, you often will see things or think you see things, or the system will think you see things that aren't really there. There are a number of really neat ways to get around that we're going to be seeing more and more in popular technology, but we're not quite there yet. But even if we are, we need to have eyewear. So, in way of concluding, I can mention that a lot has happened in the past 2 years. In 2012, and these actually are just slightly modified versions of slides at this point that I actually used in talks in 2012, Google Glass had just come out. It was something that wasn't really yet available to anyone outside of Google. There were pictures of people like Sergey actually wearing it around, and of course people got very excited about it. And this in fact helped prompt people to hear about the phrase augmented reality and talk about it. But the neat thing is that while this is what was available, or rather not available, because it was not yet something you could get even through the Explorer program in 2012, if you look at these guys down at the bottom over here, these are actually date from the late 20th century, from the 1990s. These were, in the case of the one on the left, actually available, but more as a beta unit. And the one at the bottom over there looks very much like the one at the top, because the people who did the one at the top knew about the one at the bottom. And in some cases actually included folks who wore the one at the bottom. The one at the lower right there is work done at IBM. The thing that he's holding in his hand is a 1990s ThinkPad, which has been cleverly squashed to fit inside of this thing that was more like the size of a kind of smartphone on steroids. Now, one neat thing is that there really has been progress. And so the things I'm showing you at the bottom that are being worn on the head, they are displays. They have a cable going into them, and all they are displays. The thing at the top, of course, is a full computer. It's got sensors. It's got multiple displays, audio as well as video. And it doesn't have any wires going into it, except when you need to power it, which is often. So these were promises from 2012, and actually, here's some promises from even earlier. Much more like what I think people will want to wear looks like. These are all functioning systems, but they're not things that a normal person would be able to buy. And they were available in some cases as beta units at very, very great expense, but many, many years ago. How many people recognize the person at the bottom? Anyone know who that is? Yeah, it's Tom Hanks. It's really neat how just a little bit of the eyes, right, you know, can tell you who that is. The reason he's wearing that is he participated in 2009 in Sony's keynote for the Consumer Electronics Show. And when you're Sony, you get to do the keynote for CES, and you hire Tom Hanks to wear your display. So that means you spend a lot of money on stuff like that. So that thing actually worked, but again, it was not a product, and it's not yet a product. Now, interestingly, so 2 years later, we go from 2012 to 2014, these things actually are products. Some of these have already been released. You can buy them literally right now. Others are about to be released over the next couple of months. Using the C language use of the double plus sign, I'm referring to these as Eyewear ++ because they're not just displays. They incorporate one or more of an orientation tracker or an input device of some sort, like a RGB camera and or a depth camera, a computer in the case of glass, and a couple of the other ones that you're seeing, like the Vuzix at the upper right, radio or radios to be able to communicate with other things. So these all basically are either full computers or are displays that also have sensors of various sorts, including cameras built into them. And unlike what we were seeing before, just 2 years ago, although those things were either available only as beta or were not available. And now all of these things are basically things you can buy or are about to be able to buy, in some cases admittedly for thousands of dollars rather than hundreds, but a very, very different world, I think, than we had back in 2012. So to conclude, Some of the things we're going to talk about in our workshop and things that are relevant to this kind of work are, in general, how AR can be used to help people interact more effectively with the urban environment. I talked a little bit about visualization. That's one of the things we're going to be addressing in the workshop. Navigation, how we figure out where we are and how to get to where we're going. Doing this both with AR by itself and also combined with other kinds of interaction modalities, other kinds of displays and devices. Doing it collaboratively with multiple people working together, whether they're co-located or in separate locations, and as well doing it with people working individually. Doing it in systems in which we're mobile, doing it in systems in which we're stationary, and doing it outdoors as well as indoors. And so at this point I'll stop, acknowledge the many people, students and colleagues who've worked on this stuff with me, and some of the funding agencies that provided equipment and money. Thank you.